Okie dokie. So last class, do y'all remember that last class we had something like sine of theta is equal to 1/2, and we had to go look on the unit circle to find which angle, where is sine equal to 1/2. Shake your head if y'all remember doing that last class. Okay, easy peasy, right? Like we can do that. Today, the only difference is we've got to do a little bit of math magic on our equations to make them look like that. And then once we make them look like what we had last class, we solve them the exact same way. So for this first one, the first few are pretty simple. The first one, and your goal, the only way you can solve these is it has to be one function, sine, cosine, tangent, it could be reciprocals. Trig function equals. So it has to be in that format. So right now, when we look at it, our very first equation, question number 2 from the homework, I don't have sine theta equals. I have a 2 over here. Well, can we move the 2 to the other side? Yeah, what would we do? What math operation? Divide. Very good. So let's do that. Let's move the 2 to the other side. We're going to have to divide by 2. So I have sine of theta is equal to the square root 3 over 2. At this point, this is what we did last class. We got this. So we're going to look on our unit circle. Sine. It's saying sine is positive. Which 2 quadrants is sine positive? When is y positive? On top. So it has to be the first and second quadrant. So where is sine equal to the square root 3 over 2? Daniel. Oh, you just threw on headphones and I'm literally in the middle of talking. That's rude. That's rude.
I'm sorry. I mean it like that.
Okay, so what is it? When is sine equal to square root 3 over 2? Let's answer these in radians. Dig out your unit circle. 2 pi over 3 is one of them. What's the other one in the first quadrant? Pi over 3. That is our solution set. It says that the angle could be either one of these. Also, one way to keep track and make sure that you did it correctly, this is like a check for reasonableness, they're going to have the same denominator. So I know that sometimes we can like skip and we're looking at the wrong one. They're going to have the same denominator. So keep that as like a check for reasonableness. These are both over 3. That is correct. Do y'all know how you could check your answer? You could work backwards and you could put it in there. So sine of pi over 3, and you go look on the unit circle and you find that, you multiply it by 2, this is what you get. That's what you would get. The second question, what do I need to do to solve for the angle? Divide by 2. So cosine of some angle is equal to negative square root 2 over 2. When is cosine or x, when is it negative? Yeah, it's when you move to the left. So it has to be in the second or third quadrant. That's when x is negative. So you have to go look in the second or third quadrant. And tell me what you get. Three pi over 4. And 5 pi over 4. Bless you. remember that anytime I get square root 2 over 2, it's like, I know that that one has a square root, but it's like the same number over itself. I look for the 45-degree reference angles, and it's the same for sine and cosine. So I look for the 45-degree reference angles. 45-degree reference angles are always going to be radians with a denominator of 4. And again, we can check for reasonableness because they both have the same denominator. We good so far? Let's move on. And we're working out of order. There is a method to my madness. So first we're going to look at this one. This one is a little bit different because it has two trig functions in it. So typically when you have two trig functions, or you have even the same trig function written more than once, usually the trick is that you have to factor. And so for these, it's not as easy to recognize what to do because we don't have a lot of experience factoring trig functions. But I'm going to kind of walk you through it. So I have two terms over here. Do you see something that's the same in these two terms that we could factor out? Sine. So let's factor out this sine. So I'm dividing by sine and dividing by sine. And it's going to go out into the front. So I'm going to get sine out in front. And then what I'm left with, so these will disappear. So I'm left with tangent x minus anything over itself is 1. Thank you. At this point, anytime that you have two things in parentheses or two things being multiplied and they're equal to 0, it's called the zero product property. You can set them both equal to 0 and solve. And so we have now separated so that instead of having tangents and sines together, we've separated them. So I have one thing that just has sine and one thing that only has tangent. I can work with that. So, and this only works if you're equal to 0. The zero product property does not work if you're equal to a half or something else. It doesn't work. You have to be equal to 0. And if you're equal to 0, I can split these and set them both equal to 0. So I get sine x equals 0 and tangent x minus 1 equals 0. There's not really anything else to solve for this one. But what about this one? How do I get it just trig function equals? What do I have to do? What do I have to do to get tangent by itself over here? Add 1. All right, from here, I'm going to look for two different things. I have two trig functions, so I'm going to have two sets of answers. And really, they could make up one big solution set, but I don't care if you write them separately, knowing that they're all answers. So when is sine equal to 0? Sine's equal to 0 when you don't move up or down. So when is sine equal to 0? Yeah, it's going to be left and right. So we've got 0 and pi. So we've got 0 radians and pi radians. When is tangent equal to 1? Tangent's equal to 1 at the diagonals. You have to think of a positive slope. So it's either 1 or negative 1 at a positive or negative slope. So diagonally, remember, tangent is sine over cosine. So the only place you can get 1 is when you divide something by itself. So it has to be where sine and cosine are equal. So we've got pi over 4, and what else? Five pi over 4. Very good. So all of these will work when you plug them in. So it's saying that x could be 0, pi over 4, or 5 pi over 4. If you plug it in, you'll get 0. How do y'all feel so far? Yeah? Okay. The next one. Well, I see that I've got two types of trig functions. I've got sine and cosine. To solve this one, we're going to bring the cosine over here. So first step, I'm going to subtract cosine. And this is when we're going to have to make sure that our just algebra skills are pretty on point. So we've got 2 sine x cosine x minus cosine x equals 0. And again, equaling 0 is kind of a trick. Like it's like a hint or a trick to solve these. Now, this one is very similar to this one. So what do you think we should do? Very good. We're going to factor out cosine, which means that I'm over here dividing by cosine, over here dividing by cosine. That is factoring out cosine. Anytime you factor something out, it's going to be rewritten out into the front. So I get cosine, and then I'm going to write down what I have left. So these, the cosines will cancel. So I'm left with 2 sine x. Anything over itself is 1, so minus 1 equals 0. At this point, this is the same as this. I've got the 0 product property. 2 things being multiplied equal to 0 means that I can split them and set them both equal to 0 and solve each one. So I get cosine x equals 0 and 2 sine x minus 1 equals 0. I don't have anything to solve out this branch, but in this branch, I'm going to have to get sine by itself. What would my first step be? Very well, not subtract 1. Add 1. Very good. We can't get rid of the 2 until we get rid of the 1. So I'm going to have to add 1. And then what's my next step? Divide by 2. And as you do these, you should be like, I'm kind of seeing the vision, because these are all going to be equal to unit circle values. So we have 2 branches to solve. Now we have, when is cosine equal to 0? So cosine goes with x, and when x is 0 is when you're not moving left or right, so you have to be going up and down. So what are my radians straight up and straight down? Pi over 2 and 3 pi over 2. So that's one branch solved. And when is sine equal to 1/2? Sine is going to be positive when you move up. So it's going to be in the first and the second quadrant. Sine goes with y. So when's the second value in the coordinate equal to 1/2? Very good. Beautiful. Questions so far? The curly brackets? Well, I probably should have them over here. It's a set, but it's not wrong if you have them or don't have them. This is more correct, but parentheses is 100% wrong. So parentheses indicate that it would be like a point or something, and it doesn't make sense. So curly brackets are okay. It also, if we want to get extra most correct, if you were looking up this answer or looking something up to check for yourself, it's probably going to be a list of all of them, starting with pi over 6, and then it would be pi over 2, and then it would be 5 pi over 6. And then it would be 3 pi over 2. So that's extra most correct is right here, where it lists all of them in order. But I'm okay with this too. Like, as long as we know what those answers are, we're good. But technically it is a set of answers. This is our solution set of answers. And I want to point out that the directions for this homework says, find all your solutions from 0 to 2 pi. Technically, you could add to each one of these plus 2 pi n, plus 2 pi n, plus 2 pi n, plus 2 pi n, because you could go around the circle and land at the same point. But this is asking only between 0 and 2 pi. Find your answers. We good? All right, moving on. Oh, I'm going backwards. So this is question 6 and question 8. So these look a little bit scary, but they're not really. So what we're going to do, I think I'm going to do question 8 first. We're going to go about this the same exact way that we did, question 2 and 4. That our first step would be, what do y'all think the first step would be? Divide by 2. Yep, that's the first step. And so you get cosine of 3t is equal to negative 1/2. So at this point, what we normally do, like if you ignore the 3 here, we would be looking for, okay, when is cosine equal to negative 1/2? That's what we're going to do. So when is cosine negative? Cosine goes with x. X is negative when we move left. So it has to be a value in the second and the third quadrant. So ignore that there's a 3 here. When is cosine equal to negative 1/2? Two pi over 3 is one of them. And what else? 4 pi over 3. Remember, reasonableness says that they should have the same denominator. But this time, instead of just writing theta or t, I'm going to write 3t. But our answer should be t equals. So how would I get t equals if I have a 3 in front? What would I do? Divide by 3. And so it might be good for you to write these separate, or you can kind of do your answers together. If I divide by 3, then I multiply each one of these denominators by 3. So I end up getting t is equal to 2 pi over 3 times 3 is 9. And then 4 pi over 9. Do those reduce? No. So the same thing is going to happen here, that we're going to solve it and we're going to pretend like this pi over 3 isn't there. We're just going to solve it like we're just looking for a theta or an x right here. And then at the end, if there is a value in front of the variable, you just use inverse operations to get rid of it. So what should our first step be for question number 6? Divide by 2. So we're going to take over the 2, divide by 2. So we end up with sine pi over 3 x equals square root 2 over 2. All right, so again, ignore the pi over 3. Where is sine equal to square root 2 over 2? Sine is positive when you move up because it goes with y. So it has to be in the first and the second quadrant. Okay. I'm going to do these separately because I have to get rid of this. This one's a little bit more involved than just divide by 3. All right, so now to get rid of a fraction, the fraction is multiplying, right? So we would have to divide by that fraction, right? So we would have to divide by 3 pi over 4. But when you divide by a fraction, you do keep, change, flip. So Aiden learned this last class. We're going to keep the first fraction the same. Instead of divide, we're going to multiply, and we're going to multiply by the reciprocal. Keep, change, flip. So we multiply by, not that, 3 over pi. And over here is going to be the same thing. I'm multiplying by 3 over pi. And I'll go through that again. To get rid of multiply by pi over 3, I would have to take it over here and I would divide by pi over 3. Fraction divided by a fraction means keep, change, flip, or multiply by the reciprocal. So I keep the first fraction the same. I change the operation to multiply and I flip this fraction. So it flips. I'm multiplying by the reciprocal. So now when I go to do this, if you multiply straight across, pi over pi is going to cancel. So I am left with 3 over 4. Over here, the pi and the pi are going to cancel or reduce to 1. So I'm left with 3 times 3, which is 9, 9 over 4. And that is what x equals. So there's a couple of these types of questions. You have question 5 and question 7 that you're going to do. 5, 7 looks like 13. Those all have a value with the variable. You solve it like normal, and then at the very end, you'll use inverse operations to get rid of whatever is next to the variable. Another way you could have looked at this one, to get rid of multiply by pi over 3, you're dividing by 3, so you have to multiply by 3, and then you're multiplying by pi, you have to divide by pi. That's how it technically is getting flipped. Any questions over 6 or 8? Y'all good? Okay, we're going to flip over, and I have one on the back for us to do, and then we're done. So on to the back, question number 24, we're going to do together. And then there's some others in the homework that solve very similarly. So this one, it's not super obvious at first. That's why I'm going over this with you. What we're going to do is we're going to substitute. So anytime you have a trig function and it's squared, a lot of times you factor it like a trinomial. So I noticed that I have something cosine squared plus something cosine plus a constant equals 0. This is like the warm-up. So if I take and I substitute and I say, where did my pen go? Okay, I'm going to substitute cosine x is equal to some variable. It doesn't really matter what the variable is. I'm not going to use x because in this problem it's x. So I'm just going to say that I'll call that w. It could be y, it could be anything. So I'm going to say substituting 2, and then I just substituted w squared plus plus 3, and then it's going to be plus 1 equals 0. So plus 3, and then I'm going to have a w there. So I substituted out cosines. So instead of writing cosine, I changed it to w. Everybody good with my step here? And I only do that because it's a little easier to factor when you aren't dealing with trig functions. So if we factor this, and that's what I had you guys do on the warm up, that if you factor this, you end up with 2 parentheses equals 0. And the things that they're going to have you factor are going to be pretty easy things. The only way that you can make 2 is with 2 and 1. So those are the two, we've got 2W and 1W. And what's the only two things that you can multiply together to make 1? 1. So we've got 1 and 1 will be my 2 second values. When these are both positive, so are these. And I'm betting that whatever they have you factor on your test will be something equally simple, where there's not a whole lot of options. And you could always FOIL this out and make sure that you get the same thing. At this point, I have two things being multiplied and they're equal to 0. So we've got that 0 product property, which says that we can split these. But when I split them and rewrite them, I don't want to do an extra step. So I'm going to substitute back that W is equal to cosine. So I'm substituting back. So I'll have 2 cosine x minus 1 equals 0. And then cosine x plus 1 equals 0. Everybody see what I did there? I substituted back cosine. Substituted it back in. What? Oh, I don't know. Not on purpose. Thank you. The question was, why did this one have a -1? It shouldn't have. I feel like this is, yes. Yes. Plus 2. If I did plus 2, what's 2 times 1? 2. That means that if I was FOILing it out, this would be a 2. So one way to factor is what can multiply to give you the first number, 2 and 1. So that's what has to go in front of the W. And to figure out this last number, these two values have to multiply to give you the last number. And there's no other options. If I had different numbers, I might have to play with it a little bit to see which one goes here and which one goes here to make sure that they would add up to make 3 when I multiplied it all out. But since they're both 1, there's no thinking. Just they both have to be 1. From here, I feel like this is math we can do in our head at this point. What is cosine x going to equal? What? -1/2. And on the other branch, cosine x equals what? -1. So again, I did inverse operations. I'm going to have to subtract 1, divide by 2. So I get -1/2, and I have to subtract 1. Some of these are simple. You can do them in your head. When is cosine equal to -1/2? Cosine is negative when it moves in a negative x direction. So it should be in the second and the third quadrant. So I'll make one big solution set. What do you get? Two pi over 3. And 4 pi over 3, that is correct. When is cosine equal to -1? We move in a negative x direction. It has to be at pi, and that's our only answer for that one. I don't really care if you write 2 solution sets, one here and one here, knowing that any of those answers could work. You could put them all in one solution set. Technically, the order doesn't matter. It's not an ordered pair. However, if you look up the answers, they are going to be in order as you move around the unit circle. Any questions over this one? I don't know what's on your test, but I would bet money that you'll have a question like this. Like this is a definitely a advanced skill to be able to make sure that you can factor to solve. Yes. Test is after break. So this is the last one I'm going over with you. Any questions? I lied. There's one more thing that I'm going over with you. I feel like it's very disconnected, but they ask this on the quiz. They ask for, this looks busy, so let me just explain it for a moment. They ask for the domain and range for the three trig functions, but what's strange to me is that we don't graph the functions until the next unit. So it's weird to me that you have to know the domain and range of them, but we haven't even graphed them. But whatever, we can play that game. It's not that difficult. So sine and cosine create a wave, and this wave goes on forever. However, we say that it goes between 0 and 2 pi. This is what the curve happens to look like. You don't have to know what the curve looks like because that's not the questions it asks you. The things it asks you on the last quiz that we're doing next class is the domain and range. So knowing the shape of the graph is helpful. You go from 0 to 2 pi for either one of them, whether you're looking at the sine wave or the cosine wave. Both of the domains, I'm saying that wrong. They're not restricting it. They want you to give the domain as it does make one full rotation from 0 to 2 pi, but it goes on forever. It's a wave, it goes on forever. So they want you to say that the domain is all real numbers because we're not restricting it. I said that incorrectly. They want you to know that the domain for sine and the domain for cosine is all real numbers. The other thing that they want you to be able to say is they want you to know that the sine and the cosine waves are bounded. That the highest up you can go is 1 and the lowest down you can go is -1 because it's bound by the unit circle where you can only travel up 1 and you can travel down 1. So for sine or cosine, the range, you can go up 1, down -1. So that's our range between -1 and 1. And then the other piece that they want you to be able to know to be able to do the quiz is they want you to know what the y-intercept is. So the y-intercept from sine, you start at 0, 0. The y-intercept for cosine, you start at 0, 1. So this piece of information is what you have to know to do the next quiz for sine and cosine. Again, I think it's strange that they're asking when we haven't even learned about graphing them, but whatever, that is what you have to know, this and this. For tangent, you have to know that the y-intercept from tangent is 0, 0. Tangent is a little different. It's broken. It's in these little curves. They look very similar to the cubic function. It's not the same, but they look very similar. And positive tangent goes up, negative tangent goes down. The range is all real numbers because these curves go on forever. You can see the arrows, they go on forever up and they go forever down. So the range for the tangent function is all real numbers. The domain is a little strange. So the domain, you've got these asymptotes and they happen every pi over 2. So they happen every 90 degrees. You've got these asymptotes. So the range is really all real numbers, but we don't touch the asymptotes. So you can say that the x is not equal to pi over 2, and that goes on in both directions. It's not equal to pi over 2, and you can add or subtract. It doesn't happen every pi over 2. It doesn't happen every 90 degrees. It happens every 180 degrees. I said that wrong, sorry. So we add and subtract pi in amount of times. You can go on forever. So again, this may not make a whole lot of sense, but to do the quiz, they ask you a question about the domain and range for these things and the y-intercept. So you want to take a picture and then write this stuff down. It also has to do with how you travel around the unit circle. Sine goes with y, so it's looking at the y values as you travel around the unit circle. Cosine is looking at the x values as you travel around the unit circle. And tangent is looking at that ratio of the y divided by the x as you travel around the unit circle. So this is the last little bit of information that you have to know to do the quiz that we're doing next time. So really, you know everything to do the quiz now. You can start the quiz now. And that is it. That's all, folks.